Hi, Advanced Geometry. Here's your video for section 7.5, which is on the properties of trapezoids and kites. And this slide you can actually do without knowing anything about trapezoids or kites, other than the fact that in a trapezoid, one pair of opposite sides are parallel, which I'm sure you knew already. So if you take a look at these two pictures, they have the arrows on there to show you which two sides are parallel. You're going to have to think back to chapter 3 with parallel lines and angles cut by a transversal, et cetera, et cetera. And there's a little bit of chapter 1 stuff on there, like with linear pairs and stuff like that. So take a second and try to do all of these on your own using the information that you already know, again, about parallel lines. And I will come back and give you some the answers and a little bit of explanation if you need it. Okay. Okay, so here are the answers for 1 through 6. I started with the measure of angle 1, and that one is 120 because this angle right here and this angle right here are consecutive interior angles, and the lines are parallel, so they have to be supplementary. Angle 2 and the one that's 60 degrees are alternate interior angles, and the lines are parallel, so they have to be congruent. And then angle 3, you have the same situation that you had with the 120 and 60 on the other side. Those two are consecutive interior, so they have to, again, be supplementary. So we got 90 and 90. And then similar for 4 through 6. So hopefully you were able to get all of those. And that's going to come in handy a little bit when we start talking about trapezoids, because these are all trapezoids. Both of these are trapezoids. Okay. So we're again going to be doing trapezoids and kites, but you have to have some vocabulary words first. So we've got a regular trapezoid that is a standard trapezoid that doesn't have any special properties. And then we've got the isosceles trapezoid. Hopefully you remember what the word isosceles means. Two sides that are congruent. And so that's what we've got for trapezoids as well. And the two sides that would be congruent are the ones that are not parallel. Doesn't make any sense for the ones that are parallel to be congruent, because then it would be a parallelogram and not a trapezoid. Okay, so in an isosceles trapezoid, so all of this, I don't know if I want to say that. So both of these apply to isosceles trapezoids more than a regular trapezoid, although technically there are bases and legs and base angles. But you'll see when we talk about the properties of isosceles trapezoids why we normally talk about base angles in reference to isosceles trapezoids. So anyway, for a trapezoid, the bases are parallel. So again, you might think of a base as being on the bottom. A lot of times in the lower grades, they like to think of the base as being on the bottom, but in a high school level geometry class, that's out the window. And a base could be on the top, the way they have it here. This is also a base. This is also a base, and this is a base. So in a high school level geometry class for a trapezoid, it's the bases that are parallel. So it doesn't matter what the orientation is. If I were to draw this way, where those are the two parallel sides, this is still considered a base, and this is still considered a base. So it's literally just the sides that are parallel, and that's it. Doesn't matter what the orientation is. And then the legs are the two sides of the trapezoid that are not parallel. So this one would be a leg, and this one would be a leg, simply because they are not parallel and they are in the trapezoid. They're part of the trapezoid. All right, and then we have base angles, which is exactly what it sounds like. The angles that are formed by bases, and they kind of come in pairs. So you can kind of see the top base angles, they're kind of together. They're on that same base. And then the bottom base angles, they're also together. They're on a different base, okay? All right, and again, these are usually when we talk about base angles, we're talking about the isosceles trapezoid. You'll see when we start talking about the properties, because that's where it really comes into play. All right, so then there are kites. So officially, the definition of a kite is a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. Opposite sides can't be congruent because then it would be a parallelogram, right? So you've got two pair of consecutive congruent sides. I don't know if you guys ever fly a kite. Do people do that anymore? When I was a little girl, that's what we used to do, and it was actually a lot of fun. All right, so those two sides are congruent. And then the other two sides are also congruent, but they're not all congruent to each other. So congruent, congruent, that's a kite. All right. So here's a problem that's on our coordinate plane. It says, show that ORST is a trapezoid, then decide whether it is isosceles. Okay, so in order for it to be a trapezoid, that means one pair of sides must be parallel. As we look at this, it's pretty obvious which ones must be parallel. I think it's pretty obvious. So just show that. So in order for it to be a trapezoid, one pair of parallel side, one pair of sides are parallel, and actually the other pair is not parallel. So you have to show that too. So the slope of RS is equal to, and you could use a formula if you want to. I'm going to count, but you could use a formula. So RS going up 1 and over 2. Up 1 over 2. Both in the positive direction. Up and to the right, both positive. So the slope of segment OT okay, again, I'm counting up 1 over 1, 2, up 1 over 1, 2. So it's still 1 over 2, right? Now, if I want to, I could have done 2 over 4. I'll actually do that. 2 over 4, which is 1/2. So they're the same. Okay, so these two are parallel. I just don't have enough room, so I'm just going to write the symbol. All right, so we've established that two sides are parallel. So that's good. Now we got to establish that the other two sides are not parallel. So here we go. So the slope of segment ST down 1, 2 and over 1, 2. So that would be down 2 over 2. That would be -1. The slope of RO is just down 1, 2, 3 and over nothing, which is undefined. So those are two different slopes. One of them is -1, the other one is undefined. Those are two different slopes. So therefore this thing has got to be a trapezoid. So we've done that part. Okay, so that part is in red and green. Then decide whether it is isosceles. So this is a different procedure. Decide whether it is isosceles. So if it's going to be isosceles, that means that the two sides that are not congruent, that is the two legs, have to be the two sides that are not parallel, which are the legs, have to be congruent. That's what I meant to say. Okay, so that means that we need to use the distance formula because we've got to figure out, are they congruent or not? And you might already know the answer to this, but I'm going to do the problem all the way anyway. All right, so here's the isosceles part. All right, so the length of segment ST is equal to the square root of, this is distance formula. And so I like to write, you know what, I'm going to go ahead and write the distance formula. So the distance formula is x sub 2 minus x sub 1 squared, squared, plus y sub 2 minus y sub 1 squared. So that's the formula that I'm going to be using. All right, so ST, that is the distance between S and T, is 2 minus 4 squared plus 4 minus 2 squared so that's 2 minus 4. I really want to skip, but I'm not going to. So I'm going to write -2 squared, and then 4 minus 2 is 2 squared, I'm gonna have to skip because I'm gonna run out of room. Okay, so -2 squared is 4. 2 squared is also 4. So ST is the square root of 8. All right, now RO. Now, if I want to, I can use the same formula, or this is right on the line, so I could just count. RO equals 3, right? I just counted. So again, if I wanted to use the distance formula there, I could. So ST is the square root of 8, which is not 3, and RO is exactly 3, which means this is not isosceles. So these two are not congruent. Therefore, ORST is not isosceles. Okay. All right, I hope that makes sense. All right, my other video for regular geo, I'm gonna move to that video. That's all of this is explained in that other video. So I am going to skip this right now, but I'll splice it all. So these theorems are for isosceles trapezoids only, okay? These particular ones are not for the regular trapezoids, okay? Only the isosceles. Okay, so the first one, if trapezoid ABCD is isosceles, then angle A is congruent to angle D. I should read the part above that. Above that, if a trapezoid is isosceles, then each pair of base angles is congruent. So in this case, the two top base angles are congruent and the two bottom base angles are congruent. Okay, so that's in an isosceles trapezoid. All right, the second one, isosceles trapezoid base angles converse. Well, you should have an idea of what converses are by now. So now you switch it. So if a trapezoid, I'm right here. If a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So if you know that there are base angles there that are congruent, you only need one pair, then it's got to be isosceles. Boom, there it is. All right, the other one is a trapezoid is isosceles if and only if its diagonals are congruent. So the two main things to remember in an isosceles trapezoid are diagonals are congruent and each pair of base angles is congruent. You might see that middle theorem, but we're going to concentrate mostly on the top and the bottom theorems. Okay, so remember, these are for isosceles trapezoids only. Okay, both of these. All right. Okay, so you've got this stone, it's above this archway. You've probably seen this in real life. And it's an isosceles trapezoid, and it tells us that. They kind of highlighted it, put the little marks, okay? Find measure of angle K, measure of angle M, and measure of angle J. All right, so this is an isosceles trapezoid because it tells you it's an isosceles trapezoid right there. It's also got the markings, the tick mark here, arrow here, arrow there. So it is an isosceles trapezoid. And so you're looking for measure of angle K, measure of angle M, measure of angle J. All right, the only one we're given is L, and that is the top base angle. And it is congruent to the other top base angle, which is this one. So angle K has got to also be 85. So the measure of angle K equals 85 degrees. And the reason is base angles of an isosceles trapezoid are congruent. Okay, again, those are both on the top. They're the top base angles. Okay, the bottom base angles are not also going to be 85. Hopefully you realize why. You can't have 85 plus 85 plus 85 plus 85. That doesn't equal 360. So hopefully you recognize that this, again, is a trapezoid. So this side is parallel to this side. And this is one transversal. Hopefully this is starting to look a little familiar. You've got two parallel lines cut by a transversal. An angle here is 85. So this angle in question down here is consecutive interior. So that means it's got to be supplementary to the 85. So the measure of angle M is equal to 95 because that angle is consecutive interior to angle L. All right, so again, consecutive interior angles are supplementary. So 85 plus what equals 180? The answer is 95. If you want to set up an equation there, you could do that. I just chose not to do it this time. Okay, so then measure of angle J. Well, measure of angle J is the second pair of base angles with angle M. So there was the top pair, L and K, J and M are the bottom pair. So angle J has to be congruent to angle M. So then the measure of angle J has to be equal to 95 degrees. I'll put the marks here and here. Oops. Okay, so again, this one is base angles of an isosceles trapezoid are congruent. Okay. All right, hope that makes sense. All right, next problem. In exercises 2 and 3, use trapezoid EFGH. It doesn't say it's isosceles, it just says it's a trapezoid, that's it. So number 2, if EG equals FH, is trapezoid EFGH isosceles? Well, let's take a look. EG is this diagonal. FH is this diagonal. Okay, so if those are congruent, is it isosceles? Let's go back to the theorem. So there's this theorem right here, which says a trapezoid is isosceles if and only if its diagonals are congruent. That means that it goes both ways. That means that if the trapezoid is isosceles, then the diagonals are congruent. Also, if a trapezoid has congruent diagonals, then it's an isosceles trapezoid. That's what that if and only if means. If you remember from chapter 2, it goes back and forth. All right, so the answer is yes. And I'm actually just going to write the theorem exactly the way that it appears. A trapezoid is isosceles if and only if its diagonals are congruent. Oops. So IFF stands for if and only if. All right. Next problem. If measure of angle HEF equals 70, HEF, so this entire thing is 70 degrees. And measure of angle FGH is 110, FGH. Is trapezoid EFGH isosceles? Okay. Is that isosceles? So it is telling you, first of all, that it is a trapezoid. It's not anything else. It does say for sure it's a trapezoid. So the only question is it a regular trapezoid or an isosceles trapezoid? All right, so if it is a trapezoid, because it's telling you that it is, that would mean that this side would have to be parallel to that side, because that's what it means to be a trapezoid. And it gives you the arrows here and here. So if those two are parallel and you've got that transversal, again, this angle right here has got to be supplementary to the 110. So doesn't that have to be 70? Yeah, it does. They have to be supplementary, otherwise those two can't be parallel. And then doing the same thing on the other side, this also has to be 110 because it's got to be supplementary to the 70. So then the answer is yes. All right, so I just wrote over it, so it's kind of hard. So that's an F, no, that's an EFG. Okay, EFG. So angle EFG must be supplementary to angle FGH due to the consecutive interior angles theorem that goes back to chapter 3. This is why I suggest that theorem sheet, because these theorems, they just keep coming up. So those must be supplementary. So the measure of angle EFG equals 70 degrees. Oops. No, sorry, I keep changing these colors. I'm in the middle of a video. Same for angle FHG and angle HEF. Remember, that's an E. So last part, since the base angles are congruent, trapezoid EFGH is isosceles. Boy, that's a lot to spend on one problem, but that's what we've got. That's what we've got. Okay, so those are the theorems for isosceles trapezoids, and we're about to talk about theorems for any trapezoid. So this one applies to all trapezoids. All right, so this is the trapezoid mid-segment theorem. Mid-segment. This word might sound a little familiar because we talked about it in the context of a triangle before. So now we've got mid-segments for trapezoids. And so a mid-segment for a trapezoid is pretty much the same thing as a mid-segment for a triangle, except it's on a trapezoid. So it is a segment that conjoins two midpoints. So this is a midpoint, this is a midpoint, this is the segment that connects them together. And so that is a mid-segment of the triangle, of the trapezoid, sorry. All right, so the mid-segment of a trapezoid is parallel to each base. Again, if you remember the one from triangle, it's the same thing, parallel to that third side, but in this case, we've got two. So parallel to each base, and its length is 1/2 the sum of the lengths of the bases. Again, that might sound a little bit familiar because for a triangle, it was 1/2 of that third side. This time it's 1/2 of both bases combined. All right. So MN is equal to 1/2 of both bases combined. Okay. All right, so in the diagram, MN is the mid-segment of trapezoid PQRS. So it is telling you right now, it is a mid-segment, check. find MN. All right, so once again, MN is equal to half of the two other bases combined. When I say combined, I mean the sum of. So that would be PQ plus SR. All right, so MN is equal to half of PQ, which is 12, right there, plus SR, which is 28. So 12 plus 28, that looks like 40 to me. Half of 40 is obviously 20. Now, on some of these, you may have noticed that 20 is literally right in the middle between 12 and 28. If you count up by 8, you'll get 20. You count down by 8, you get 20. So that is a little bit of a shortcut there. But if you need to show your work, which, as you know, is often what happens on some sort of a quiz or test, then you have a formula. All right. Okay, in trapezoid JKLM, JK is 9 centimeters. The length of mid-segment NP of trapezoid JKLM is 12 centimeters. Sketch the trapezoid, and its mid-segment, find ML. Explain your reasoning. Okay, so this is kind of a lot, but we can do it. Okay, first of all, it's trapezoid JKLM. JKLM right here. So I'm going to draw that. JKLM. Keep in mind, you got to go around on all of these polygons. You got to go around. You can either go counterclockwise or counterclockwise. That part doesn't matter, but you cannot go JKLM. You cannot do, I'll do it real quick. You can't do JKLM. That does not work. Okay, can't do that. All right, so JK is 9 centimeters. The length of mid-segment NP. Okay, so our mid-segment is NP, because it tells us that, is 12. Sketch the trapezoid, we did that, and its mid-segment, we did that, find ML. Okay, so you could do a formula here, or you could count. So remember, when I did this one, I mentioned that 20 is in the middle between 12 and 28. That's what it means when you add them up and divide by 2. You're going to get something that's in the middle, right? So you could do that. That might help you on this one. Except you would have to figure out, okay, what's the difference between 9 and 12? Well, of course, that's 3. So then you keep on going, add another 3, and you get 15. So this one's going to be 15 centimeters. Because again, the distance between 9 and 12 is 3. So the distance between 12 and whatever has to be 3. And that whatever is going to be 15, because 12 plus 3 is 15. So you could do it in your head. You'd have to explain that. Or you could use the formula. So I'm going to go ahead and use the formula. Oop, not MN. The mid segment is NP. NP is equal to half of JK plus ML. All right, in this case, the thing we don't know is ML. We do know NP. NP is 12. It is equal to half of 9 plus ML, which I don't know what that is again, because I mean, I do, but we're pretending like we don't know. All right, times 2, that gets rid of the half, and I have 24 is equal to 9. Well, it's so hard to write on here without putting my hand on there. 9 plus ML, subtract your 9 and you get 15. 15 equals ML. So that's if you just want to show some work. If you want to explain your reasoning, you could say something like, use the same mid-segment formula that we always do, and plug in the numbers in the appropriate spot if you show the formula. If you don't show the formula, then you have to explain that. You have to explain that JK is 3 units away from NP, which means continuing on with that pattern, 3 units away from NP going the other way is 15. So I'm not going to write all of that because it all depends on how you want to explain it, but hopefully you have an idea of what you need to do together later. And then we come to this problem, which is for advanced geo. All right, so this problem says find the length of mid-segment YZ in trapezoid STUV. Well, you probably know how to do this already. Maybe, I don't know. Hopefully you recognize that length means that we're gonna have to use the distance formula. So we're gonna use that again. I'm gonna go ahead and write it one more time. So D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That's our distance formula. Now, as I look at this picture though, that z is problematic. The y looks like it's right on the lattice point, but z does not. So let's make sure that y and z are where they're supposed to be, and let's figure out exactly what the coordinates are of z. So in a mid-segment, that is the segment that combines the two midpoints. So that means y has to be a midpoint because it tells us that the segment YZ is a mid-segment. So this must be the midpoint of ST. And this one must be the midpoint of VU. So that means I got to figure out exactly what the midpoints are. So that's what I'm going to do. So then before I start with the distance formula, I'm going to use the midpoint formula. So that's x sub 1 plus x sub 2 over 2 and y sub 1 plus y sub 2 over 2. All right, so y is 0 plus 8. I'm just going to skip over 2, which is 4. At first, I wasn't going to skip. I'm just going to have to skip because I don't have a lot of room. All right, 6 plus 10, 16, divided by 2, 8. Okay, 4 comma 8, and that's exactly where it is. That's 4, and that is 8. Okay, 4 comma 8. That's perfect. Z. All right, that one is 2 plus 12. 2 plus 12, which is 14, divide by 2. So that's going to be 7. And then, so I'm right here. So 2 and 12, those two added together. And then 2 plus 2, and then that's going to be 4 divided by 2 is 2, 7, 2. All right, so that's why it looks like it's in the middle because our each square is worth 2. So that's why it's in the middle. So it is 7 comma 2. So these are the points that I'm going to use in the distance formula. So I'm going to make, let's see, my green ones, I'll make those x sub 1, y sub 1, and then the other ones in pink, I'll make those x sub 2, y sub 2. All right, going back to my distance formula. So just plug and chug. So that's going to be 4 minus 7 squared plus 8 minus 2 squared. 4 minus 7 is negative 3. 8 minus 2 is 6. 9 and 36. Looks like that's going to be the square root of 45. Now, if you know how to simplify that, you can simplify that. It doesn't say whether you have to leave it in simplified form. It doesn't say whether you can give me a decimal. So if it doesn't say, you get to do whatever you want. Now, at some point, once we have gone through how to simplify, you need to always simplify. But at this point, we haven't talked about that, so you can leave it however you want. I'm going to go ahead and simplify, and I'm also going to change this D to YZ. All right, so square root of 45 can be turned into the square root of 9 and the square root of 5. The square root of 9 is a perfect square, so 3 radical 5. So YZ is equal to 3 radical 5. If you're the type that likes to put it on the calculator, square root of 45, approximately 6.7. I am not sure which one will be in the back of the book when you do these problems, because I have not looked at the back of the book to see what their standard is for this chapter. So they might have either one. All right, hope that made sense. This one is in the other video. All the rest of these are in the other video. So I'm just going to splice it together and that's going to be it, except these last 2 slides, we will do those in class. Okay, so the next 2 theorems are all about kites. And hopefully you guys know what a kite is. I don't think people go fly kites anymore. When I was a little girl, that's what we used to do. We'd go fly a kite. It was actually a lot of fun. I'm not sure if you guys do that anymore. But anyway, so a kite is an official geometric figure, just like a trapezoid is, or a parallelogram, or anything else. And so a kite is going to be a quadrilateral whereby 2 sides are congruent to each other, and the other 2 sides, 2 consecutive, those are consecutive. So both pairs of consecutive sides are congruent. So that's how they often define a kite. Okay, so if a quadrilateral is a kite, which again looks just like the picture here, then its diagonals are perpendicular. So just like it looks like here, this diagonal CA and this diagonal BD form 90-degree angles. That's what it means to be perpendicular. There you have it. Okay, and then this one, yes, the kite opposite angles theorem. So in this one, if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. Now, one thing that they don't tell you is there are actually vertex angles and non-vertex angles. So you know what? I think I'm going to pause here for a minute and I'm going to go to a website so I can show you exactly which ones are which. So I will pause and come right back. Okay, so here are vertex angles. These are, I can't write on there, but you can see from the picture which ones are vertex angles. So you see where the 2 congruent sides come together, those are vertex angles, okay? So where the 2 congruent sides meet, the ones with the double tick marks where they meet, that's a vertex angle, single tick mark, that's where they meet. And then the other ones are non-vertex angles, okay? Non-vertex angles. All right, so this is why I pause. Okay, just a minute. Okay, so the vertex angles on this one would be angle B and angle D. The non-vertex angles are the ones that are congruent. So angle A and angle C are non-vertex angles. And they are the ones that are congruent. And I bet you that's not even in your book. That's why I had to go elsewhere. I don't know, for some reason they leave that out of books. I don't know why, because I think that helps keep them straight. All right, so it's the non-vertex angles that are congruent. Okay, so it's where the single tick mark and the double tick mark, where they meet. That's congruent to the other single tick mark and double tick mark, where those 2 meet. Okay, all right. All right, so here we go. Find measure of angle D in the kite shown. All right, so in this kite, we've got a single tick mark here, a single tick mark here, and then double tick mark here, double tick mark there. Okay, so the non-vertex angles are angle D and F. So that's where the single and double tick mark segments meet, D and F. All right, so angle D is congruent to angle F because of that theorem from before about, it doesn't say non-vertex angles, but I'm telling you it's what it is. Okay, so it says exactly one pair of opposite angles are congruent. The other ones aren't congruent. It's only the non-vertex angles. All right, so angle D is congruent to angle F, and we know that this thing is a quadrilateral. So all of these angles add up to 360 degrees because that's how it is for all quadrilaterals. So I can do a little equation. I can do 115 plus 73 plus, I'm going to say that the measure of angle D equals the measure of angle F, and I'm going to say they're each equal to X. So 2 times X is equal to 360. So again, I can only do that if they're equal. I can't do that if they're not equal, but in this case they are. All right, so 115 plus 73, what's that going to be? 188. Subtract by 188. Let me do that over here real quick. So it's going to be 172. Divide by 2. 86. 86. Okay, so the measure of angle D equals the measure of angle F, which equals 86 degrees. There you go. Okay. All right, I think you can figure out number 6. Try number 6, and I'll come back. Okay, so hopefully you put together an equation that looks something like what you see in green there. So the directions say to find the value of X, which is 15. Hopefully you got that right. And then the second part says, what are the measures of the angles that are congruent? Well, we've got 3x, which we also know is 75 because you just plug in the 15 and you get 75. And then you got 75, 90, and 120. And the questions is asking me what are the measures of the angles that are congruent. So the answer to that part is 75 degrees and 75 degrees. Those are the two angles that are congruent. So that is for the highlighted part. And then the other part is the value of X. Okay. All right. So there is one. Okay. All right. Hope you guys have a great day. Bye.